What if you could send data wirelessly using just two Arduino and pair of LoRa modules? In this video, we will start with simplest test by sending hello message from one Arduino to another. Once we have confirmed the communication is working, we will take it a step further by connecting a potentiometer and transmitting its value in real time. On the receiver side, you will watch the data appear instantly on an OLED display. Whether you are building IoT devices, remote monitoring system, or long-range wireless project, this tutorial will give you a solid foundation in LoRa communication. So let's get started and build it together. We will require the following components for this project: Arduino Uno, Arduino Nano, LoRa module, SSD1306 OLED display, potentiometer, breadboard, and some jumper wires. LoRa, which stands for Long Range, is a wireless communication technology designed to transmit small amount of data over very large distances while consuming very little power. Unlike Wi-Fi or Bluetooth, LoRa can communicate over several kilometers in open areas, making it an excellent choice for battery-powered IoT devices. LoRa operates in license-free ISM frequency bands such as 433 MHz, 868 MHz, and 915 MHz, depending on the country and region. It is commonly used in applications like smart agriculture, environmental monitoring, smart cities, industrial automation, asset tracking, and home automation. One of LoRa's biggest advantage is its combination of long communication range, low power consumption, and good resistance to interference. It consists of following pins: VCC power the LoRa module. Most SX1278 operate at 3.3 volt, so never connect the pin directly to 5 volt. Your module includes an onboard voltage regulator. Ground connection connected to Arduino ground pin. SCK SPA clock pin used to synchronize communication between the Arduino and the LoRa module. MISO transfer data from LoRa module to Arduino. MOSI transfer data from Arduino to the LoRa module. NSS used by Arduino to select the LoRa module during SPA communication. In this project, it is connected to digital pin 10. RST reset the LoRa module. DIO0, a digital interrupt pin that signals when a packet has been transmitted or received. The circuit diagram for LoRa module will be same for both transmitter and receiver. The VCC of the LoRa module is connected with 3.3 volt of the Arduino Uno. The MISO pin of the LoRa module is connected with the Arduino pin 12. The MOSI pin is connected with the Arduino pin 11. The SCLK pin of the LoRa module is connected with Arduino pin 13. The NSS pin is connected with the Arduino pin 10, and ground pin of the LoRa module is connected with the Arduino ground. The RST pin is connected with Arduino pin D9, and DI0 is connected with Arduino pin 2. Now similar connection is used for the Arduino Nano. The VCC of the LoRa module is connected with 3.3 volt of the Arduino Nano. The MISO pin of the LoRa module is connected with the Arduino pin 12. The MOSI pin is connected with the Arduino pin 11. The SCLK pin of the LoRa module is connected with the Arduino pin 13. The NSS pin is connected with the Arduino pin 10. Ground pin is connected to ground. The RST pin is connected with Arduino pin D9. And DI0 pin is connected with Arduino pin 2. Now let's connect the SSD1306 OLED display. Connect the VCC pin of the SSD1306 OLED display with 5 volt, ground pin with ground, SDA pin with A4, and SCL pin with A5. Let's briefly understand how the transmitter code works. First, we include the SPI and LoRa libraries. The SPI library allows the Arduino to communicate with LoRa module, while the LoRa library provides function for sending and receiving data. Next, we will define the chipset, reset and DIO 0 pin used to connect the LoRa module to the Arduino. Inside the setup function, serial communication is initialized at 9600 baud, so we can monitor message on the serial monitor. The LoRa.set pins function assign the LoRa control pins, and LoRa.begin 433 E6 initialize the module at 433 MHz. If initialization failed, the program display an error message and stop running, otherwise it print LoRa transmitter ready to indicate that the module is ready. Inside the loop function, the Arduino create a new LoRa packet using LoRa.begin packet. Write the text hello into the packet using LoRa.print and then transmit it using LoRa.end packet. After sending the message, it prints message send hello on the serial monitor and wait for 2 seconds before sending the next packet. As a result, the transmitter continuously sends the hello message every 2 seconds, which can be received by another Arduino equipped with a LoRa module. Now let's understand the receiver code. First, we include the required libraries for SPI communication, LoRa communication, and the SSD1306 OLED display. We also define the OLED screen size and create a display object to control the screen. In the setup function, serial communication is started at 9600 baud and the OLED display is initialized. If the display cannot be detected, the program prints an error message and stops. Otherwise, a starting message is shown on the OLED. Next, the LoRa control pins are configured using the LoRa.set pins, and the LoRa module is initialized at 433 MHz using LoRa.begin. If initialization fails, an error message is displayed on both the serial monitor and the OLED. If successful, the OLED displays LoRa receiver ready, indicating that the receiver is ready to receive packets. Inside the loop function, the program continuously checks for incoming LoRa packet using LoRa.parse packet. When packet is received, the data is read character by character and stored in string. Finally, the received message is printed on the serial monitor and displayed on the OLED screen. The code also shows the RSSI value, which indicates how strong the received LoRa signal is. This process repeats continuously, allowing the receiver to display every new message sent by the transmitter in real time. I have powered up the receiver circuit first. As you can see on the OLED display, it shows LoRa receiver ready, which means the receiver has been initialized successfully and is waiting for incoming data. At the moment, the transmitter is turned off, so the receiver is not receiving any messages. Now let's power on the transmitter. As soon as the transmitter starts sending data, you can see that the receiver instantly displays the hello message on the OLED screen. This confirms that the two LoRa modules are communicating successfully and the wireless link has been established. With the communication verified, we can now move on to transmitting real-time sensor data such as potentiometer values using the same LoRa connection. Now I will connect a potentiometer to Arduino Uno so that we can transmit its analog value wirelessly. The VCC pin of the potentiometer is connected to 5V and ground pin is connected to ground. The middle pin, also known as wiper, connected to the anode analog input pin. Now that the circuit is powered on, the transmitter starts reading the potentiometer value and send it wirelessly through the LoRa module. On the receiver side, you can see the value appearing on the SSD1306 OLED display in real time. As I rotate the potentiometer knob, the analog value changes continuously from 0 to 1023, and the updated value is transmitted instantly. The receiver successfully receives each new value and display it on the OLED screen without any noticeable delay. This demonstrates that our LoRa communication is working reliably and can transmit real-time sensor data wirelessly over a long range. And that's it. We have successfully built simple LoRa communication system using Arduino Uno and Arduino Nano. We started by sending a basic hello message to verify the wireless connection, and then we transmit the real-time potentiometer values and display them on the SSD1306 OLED screen. This is just a beginning. Using the same setup, you can send data from various sensor, control devices remotely, and build long-range IoT projects such as weather station, smart agriculture system, home automation, and remote monitoring application. If you found this video helpful, don't forget to like, share, and subscribe to the channel for more Arduino, ESP32, IoT, and embedded system project. If you have any questions or suggestions, let me know in the comment below. Thanks for watching, and I will see you in the next video.